Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. Last video, as I told you, we finished the theoretical part. Now we will see the numerical parts. Okay, so let's start with the numerical. So first question is, an infinite plate contains a crack having an initial length of 0.2 mm and is subjected to a cyclic repeated stress range of 175 Newton per meter mm square. If the fracture toughness of the plate is 1708, that is 1708 Newton per mm power 3 by 2, that is the unit, and the rate of crack growth is 40 into 10 to the power minus 15 into delta k power 4 mm per cycle. Determine the number of cycle to failure. Means here what we have to find, after how many cycles that structure or frame, whatever is there, that will get cracked or fail. So let's see. First, recall some formula what we had seen in earlier videos, right? In this formula also I told you that whatever if SR is there, then that will be variable. So we will start with this formula, right? So this formula already we had seen. Now from here, Kp is what? SA and power 1 by 2 alpha, right? Where Kp is the stress intensity factor, but already this is the stress intensity factor from the same only. Now just see here. Just what we can write this as, if suppose this is S, right? So S equals to, we can write S equals to K by 2 pi R power 1 by 2 into F of theta, right? So this can we write as A. So this will give you what? S equals to K by A into F theta. Now what you have to find? K. So K will be here, let's multiply. This will be S into A into 1 by F of theta, right? That only is the, you can say, the coefficient, non-dimensional coefficient here. So with this what we will get? K equals to S A, right, power this one, and so from here only we can write this as S equals to this term, that pi A1 power 1 by 2 into alpha 1, right, for first coefficient. So that's why alpha 1 is here, A1 we can take. For alpha, this will be as A. So S pi A power half into alpha. So this is the intensity factor from this equation we can get. That later we will use to find this one, right? So let's see here, where alpha is a non-dimensional coefficient usually expressed as the ratio of crack length to any convenient local dimension in the plane of the component. So see, crack length, right? Where already we had seen that R was the crack length, right? Sorry, 2A was the crack length and R we assumed where we are finding. So that this one R should be less than equals to A, right? For a crack in infinite plate under an applied uniform stress level S. So here S is applied stress removed from the crack. Alpha is what? 1.0. So here we will take alpha as 1. So what we will get? K equals to S pi A power 1 by 2. So now our K will be pi A power 1 by 2 when alpha is 1. Now, under constant amplitude loading, the rate of crack propagation may be represented graphically by the curve prescribed in general term by the law. So now this law we can see, so dA by dN, which gives F of R, K from the same, similar to the previous equation, right? So this is in which K is the stress intensity factor, that already we know. R is what? S mean by F max, that is minimum stress by maximum stress. Here R is there. So now what will, then delta will be what? Range. In our numericals also the range is there, range is given. Okay, so here in terms of the same formula, this one, right? If we will write in terms of range, then what happened? S maximum minus N minimum, sorry, S minimum. So S here, this becomes range. If range is there, if directly a stress will be given, then we can use directly S. But in range, so S max minus S mean, into pi a power 1 by 2 into alpha, right? So this is for when in terms of range is given. If directly it's given the stress, then we can directly apply S instead of S max minus S minimum. So in our question, range is given, that is S max minus S mean. This value directly given in the question. So now same for Kp, this will be what? S max minus S mean by A1 power half alpha 1, right? So this assumed as equation 3. So dA by dN will give you what? C delta K, that is this one, power N, right? This is our equation 4. The C here, now what is C? C and N depends on the material property. So this is what? Constant, and that depend on the material property depending upon which type of material is there. So if numerical will be there, then they will give the value of C and N also. Overall, over a small range dA by dN, K, C and N remains approximately constant when we are finding for the small range, right? Then we are assuming these things are constant. So now just from the previous formula here, right? So now dA by dN is C delta K power N by N divided by 1 minus R of Kc minus delta K. Now here Kc is the fracture toughness of the material. What is Kc? Fracture toughness of the material obtained from toughness test. So again, if this is required, then this will give in the numerical, or else we have to consider as 1. Now what we have to do? Just integrate this one. So take cross multiply. So after that, what we will get? We have to find this dN, right? So let's first see this one, or just take here. So dN into C delta K power N will be equals to what? 1 minus R Kc minus delta K into dA, right? This we have to integrate both depending upon the limit. So limit from where we will take? Initial to the final, Ni to Nf. Ni will be what? Starting 0. So that we will take later that Ni as 0, because at the starting point no number of cycle is there, so 0 will be there. So now after integrating this one, right, by separating this, so from here that we can write dN equals to 1 minus R Kc minus delta K into dA by C delta K N. So after integrating and putting the proper limit, again A will be from what? AI to AF. We will get this value after integrating this one. Okay. Now substituting the limit, put Ni equals to 0. Number of cycle to failure is given by. So once you will put the limit here, what? AI and AF. So what will be AI here? So from where we are finding. So just see here AI, AF, right? We have to put the value here. N will be what? Value of N. You just okay on this one. Just after substituting. Later we will see for the numericals what happens. So this is after substituting the limit and Ni equals to 0. This we will get the formula. And now this we will use in our numerical to solve, to find number of cycle after which the member or structure will fail. So this one is required. Okay. Now let's see. Now come to the question, whatever is given. The crack length at failure is given. Just now we derived this one, where alpha equals to 1 and K is given 1708 Newton per mm power 3 by 2. So now AF formula. What was the AF formula? So just see from here, right? This is K equals to, we have the formula K equals to pi a power half Here S is there, here alpha is there. Here we have to find F. So final F means just take here F. Now what alpha is 1, right? So alpha we can remove that one. So K equals to S pi AF power half. This is our formula. Now from here we have to find AF. So what we will do? Sorry, actually this will be there. KAF power 5. Now, so first divide this one. So K by S. Okay? Now, K by S equals to pi AF power 1 by 2. Now square both sides. So what happened? K by S, or you can write that K square by S square equals to pi AF. Because after squaring, this will get cancelled. So here A of F. So from here A of F will be equals to K square by S square and into pi. So here this is what? So now our formula is AF equals to K square by pi into S square. K given, pi is pi, and S is given as 175. After putting this one and just multiply the first square it, multiply, and that means just by solving you will get AF as 30.3 mm. That is the length of the crack. Right? Now next we will see what we derived from this formula. Now we have to find number of cycles. So how we will find number of cycles? So again for this one, let's see here. So whatever this is there, that we will put in the next equation and we can find. So now NF is 1 by, so let's see here, for this material that value of this is C of this one Sn minus 2, for n equals to 4 we are taking. So that substituting the relevant parameter in equation 7. So now in this once we will submit, right, S max minus S mean, directly it's given what? 175. Right? Then what is required? Next pi power 1 by 2 is there, and here n we are taking as 4. So this power 4 will be there. C n minus 2. So C into 4 minus 2. So okay. So let's put here this one, or just according to this formula I am writing itself here 2. Okay, so now just put values here 2 and C, this one C is 40 into 10 to the power minus 15, 40 into 10 to the power minus 15. Okay, and 4 minus 2 as max and minimum is given as 175. Okay, and then pi power 1 by 2 into 4, right? So this is the whole power 4, not into 4, and by 2. So after simplifying, first let's simplify this part. So what happens, this 4 minus 2 will be equals to 2. So this 2 we can cancel. So now what we have, 1 by 40 into 10 to the power minus 15, right, into 1 by 175 pi power 1 by 2, and this whole power what, 4. Okay, so first part solved. Now come to second part. What is here? 1 by AI n minus 2 by 2 and minus 1 by AF n minus 2. So just now we found this one, AF, right? So after finding this, and n is 4, so 4 minus 2 by 2, that is 2. So this, after simplifying this term, what we can write? This as 1 by AI minus 1 by AF. So this term will be 4, n equals to 4. Now, so this term into this term we have to find. Now what we have? 1 by 40 into 10 to the power minus 15, okay, into 1 by 175 into pi power 1 by 2 and whole power 4 into 1 by ai minus 1 by af. Right? That is here what we got. We found 30.3 as AF. AI is given. After putting these values, what happened? We will get, after calculating, or just in calculator also you can put these values, you will get NF equals to 26919 cycle, meaning what? 26,919 cycle. After that, the structure will fail. So when after 26919 cycles, that a structure will fail. Now just see, so this is the final answer. So this and this only is required. So we found. Now just see with this, if suppose they will change the question and how they can modify or change the question. Here, this we found in terms of R. Now next, same thing will be for in terms of S theta, right? So then we have to take again in terms of theta. So whatever is there in terms of that only we have to find, keeping in mind that alpha value. What is alpha? That already we had seen. What is that? It's a non-dimensional quantity. Because of the same type we are dividing. It is what? The ratio of crack length to any convenient local dimension in the plane. So how much the crack length is there? If suppose this is, so from here to your crack length, right? So if suppose this is 2 mm and you are finding for somewhere here at that same R value, that R, right? So this is as 1 mm, or that may be 0.5 mm. That depends on the given question. So this 2 divided by the 0.5. So here alpha will be what? Alpha equals to, so alpha will be equals to 4. So in this case, alpha will be 4. So depending upon where you are finding, based on that you can find. So here just I assume that's 2 mm. So here alpha is 1. That's why we substituted alpha as 1. Now, so K in terms of S, directly by this you can find. No need to use the range, right? If in terms of range is there, then simply as just earlier told, you just go and take this value and that value is given. Now, instead of giving the range directly, what they can do, they will say the maximum stress. S max, they will give the values, right? S mean, that is S minimum, they will give the values. They won't give directly the maximum or range. They will give this value, right? This value means what? Meaning is same. Again, you have to take the difference of these two, S max minus S mean, you will get range. Or else simply this, use this formula, put here, right? So don't confuse with the word. Whatever is there, just see what exactly is there. Either it's given in the form of range or it's given in the form of what? S max and S mean. One more thing, instead of that they won't give this S mean. Then what happens? Simply S max they will give, means S mean is, just assume S mean as 0. So for maximum stress, whatever the Kp value will be there, that you will get. Just use S max, no need to use S mean. So means S mean, S max minus 0 equals to pi a1 power 1 by 2 into alpha 1. Simple, right? So S mean will be equals to 0. So simply you can put and then you can find. Clear this one? So just see again, after integrating only you will get this part. Okay, so this is the integrating part that I skipped. How to integrate? Just by knowing, okay, you know the integration. So this is just integration what I earlier solved for that one. Now here one more changes will be there. So then just see, AI is given already. Let's see here, having an initial length of 0.2 mm, right? Initial length means crack, what is the R? Half of that one, that only we used in what? As I equals to 1, because 2 mm is there and already we had seen that half of that crack length is A. So we used that one. Now just see one more type with the same thing we can find, right? So n equals to 4 we have taken. Now instead of giving the crack length, they will give both the crack length. So means like in a starting crack length is, let's see, same problem in how many different ways they can ask. Now what they will do, they will give this and this, that means AF final crack and initial crack, their value they will give. Now they will ask to find how much or which is range of the stress is required, so that in starting or in simple way, a material or a structure having the initial crack length of 0.2 mm, okay, and how much stress should apply or act on that so that the crack propagates and the size becomes to 30.3 mm. Means what? Now they given AI and AF. So now this is not required. This already is given. So these two is given. Now only just we have to find this one. That time they will give this value NF. After how many cycles this crack size becomes this one. So that can be another equation. That's question. So first read the question properly, what they are asking, related to that whatever the formula is there, just recall and then find. So better first whatever the formula related to that is there, right? Just write that formula and then see what is actually required. Write as a question mark what you have to find, and then you just put those value, find that value, you will get the answer, right? And especially this one is very important for solving the problem. This space is not required what we had seen for the numerical, but just to clear what is the formula, how that formula we got, because in previous video we haven't seen this one. So that's why I just mentioned here this formula. So but this formula, this derivation is not required for the solution of this question. Directly you can use these two formula by writing like we know this one, but here this formula. So this formula and next this formula and substitute the value, you will get the answer. So if with this any doubt is there, you can just comment on the video link, or you can directly contact me regarding your doubts. Okay, in our next video we will see, this video will stop here because one topic related numericals got over. In next video we will see another numericals.
Like, share and subscribe. Hit the bell icon for more updates.